You know that part where you get through the queue and you finally get to the front of the queue and you get to ride next? You know that feeling? You know how exciting it is to be next? You know what's really cool? We're next. We get to do this. Isn't that cool? Here's the part where I tell you I am definitely going to post my slides online, and there aren't any, so I'm not going to post them online. But we're going to take a tour of ASP.NET Minimal APIs. We're going to start with an ASP.NET 5 project, upgrade it to .NET 7, and see all the cool C# 10 and 11 features that we get to leverage in that process. All live coding. The code is online right now. So you can grab the code from this URL up on GitHub, github.com/robrich/minimal-apis ASP.NET. All of the things that we're going to do today, it's online right now. Achievement unlocked. Woo! So each of the steps that we'll do is a separate folder, so you can pop open that folder and take a look at the things. And by the way, I didn't push refresh here. I updated a few things yesterday. This will be really cool. If this URL is a little bit too far, you can head to robrich.org, click on presentations here at the top, and here is Minimal APIs with ASP.NET and a link straight to that code. So robrich.org may be an easier way to get there, and at that point, then you can grab the code. While we're here on robrich.org, let's click on About Me and see some of the things that I've done recently. I am a developer advocate for Shoreline, and both Docker and Microsoft have given me some awards as well. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver completed software to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp, or if you'd like a Give Camp here in London or wherever you came from, wherever you traveled from, find me here at the event, hit me up on email, Twitter, or Mastodon, and let's get a Give Camp in your neighborhood too. Some of the other things that I've done, I'm a friend of Redgate, pro microservices in .NET 6. That was a lot of fun to write. I got to work with my friends Sean and Matt on that. I run a user group in Utah and one in Arizona. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comments on the air, and they sent me a mug. Woo! So there's my claim to fame as my coveted .NET Rocks mug. And if you'd like a .NET Rocks mug, no, I'm just kidding. Richard's talk this morning was amazing, though. So let's start with some interesting things. I've got a folder here. It has exactly one file in it. Let's open this up in VS Code. I could have scaffolded it out or typed out the CSproj file, but basically it just says, I'm a .NET website. In this case, it's .NET 7. It's a website, and that's pretty much all it says. So let's create a new file. Program.cs. Oh, thank you, VS Code. Yes, it creates this .vs Code folder that gives us some interesting things for debugging. We'll nicely ignore that. And let's write a web server. var builder equals web application.create builder. Yeah, I'll pass in the command line arguments. That works. Var app equals builder.build. App.run, that will start up my web server. What do I want my web server to do? App.map.get, I'll map the home page to this function, and GitHub Copilot has seen me do this a little bit. So let's say new, we'll give it a new object. Nope, not a task. Message equals hello world. But in case somebody wants to pass in a name, I'll make that optional actually. And let's say hello world, or let's say hello name. Let's make that a string like this. And I'll even give it an optional NDC London. And that will do that. Cool. So now that we've got our web server built, let's say .NET run, and we'll, oh, it looks like I haven't run .NET 7.0 the patch that came out yesterday since yesterday. Okay, so we've got our web server running. Excellent. Let's come here to localhost 5000, and we can see that our web server is running. This is cool. Now, if we pop open the developer tools and reload it, we can see that this is giving us a 200. We've got the correct response headers, content type application JSON. Let's type in /name equals foo, and we can see that it's doing URL parsing as well. That's pretty cool. So we took in this piece, it's pulling data out of our query string, automatically binding it to our parameters, outputting correctly formatted JSON, and all of that in a server that is 4 lines of code. Now that's pretty cool. That's not the code that I wrote yesterday, though. How did we get here? I remember the movement where we started talking about Visual Fred as we moved from from VB to VB.NET, and we're like, but this is too weird. So let's take a step back and see how we got here. So if I'm in Visual Studio and I wanted to scaffold out a project that kind of had that minimal API and got all of the files set up, I did a new WebAPI project, and there's this checkbox right here that says use controllers. I uncheck that, now I'm using minimal APIs, or I can check that and now I'm using controllers again, and that'll just get me started. But in this website, I've got a .NET 5 website, so we're gonna see that nice warning down here in the build saying, but it's not supported anymore. Yeah. But we've got this .NET 5 website, and as the website starts up, we can see we have a home page, we've got an about page, we've got an API that'll show us weather details, we've got Swagger so that we can try it out. Let's click try it out and execute, and we can see that we've got some JSON results. Now, what's interesting about this website is that we're actually using all 3 paradigms of hosting content in .NET. So here's our website, and we have a home controller. Here's our home controller. We have an index view. We can come into the views folder, and there's our index view, and here it says our home page. So typical .NET 5 website. We rigged this up because here in startup.cs, we start off by saying add controllers with views. And then down here at the bottom, we say map controller route. And that's what fires up ASP.NET MVC to be able to detect those controllers, match them with the views, and everything works out great. What's interesting, though, is that's our home page. If we go to the About page actually uses Razor Pages. So Razor Pages is excellent for being able to map a particular URL to a page. We could think of this kind of like classic ASP. We don't want to do those layers of indirection. We just want to go straight from a URL to a page. So here's our About page, and that's working with Razor Pages. We can see the Pages folder and the About CSHTML. We've got Razor Pages. Well, how did we rig up Razor Pages? Here in the startup, we can see that we say .add Razor Pages. So that will go scan our Razor Pages folder, our Pages folder. We also have map Razor Pages, and now our Razor Pages light up. But we also have WebAPI in this, and that's powering this weather forecast controller and our Swagger page. Well, how did we rig that up? Well, here's our weather forecast controller that, by the way, is a controller. Because it's a controller, here in our startup.cs, we said map controllers with routes, which nicely mapped all of our WebAPI controllers too. That's excellent. And then we also added Swagger, and we added the Swagger UI. Now, we chose to add the Swagger UI only in development, so that if we publish it to production, those API endpoints are not as discoverable. That is definitely not a security mechanism, but we're kind of using it to kind of aid security a little bit. It's discoverable in development, it's not discoverable in production. If we did want to change that, if we did want to make them discoverable, we could put those out here, and now Swagger is available in production as well. So we have all 3 paradigms. We have MVC, we have Razor Pages, and we have WebAPI. Yeah, in the new project dialog, there are checkboxes, and we have to check one or the other. But they're just adding these lines, and so we've got all three of them. Now, I probably wouldn't use all three in one project. I would probably pick the one that makes the most sense. But I wanted to show how we can upgrade a .NET 5 project to .NET 7. And if you're using any of these three paradigms, which are all of them, then you're not going to be left out. So let's upgrade from .NET 5 to .NET 7. Now, we could definitely come in here to the properties, pop open the property grid, and do all the things. But what we're going to do to upgrade from 5 to 7 is change the number from 5 to 7. That's all the dropdown does. Welcome to .NET 7. We just upgraded. If that's all you do is upgrade from .NET 5 to .NET 7 by changing the number, you will immediately see performance benefits. They've done a lot in reducing allocations, using span of t. The framework is just faster. And so if you get nothing else, come into your project, upgrade it from 3.1 to 5 to 7, from 5 to 7, from 6 to 7, and you will see performance benefits. Okay, let's take it a little bit further. I'm going to come in here and I'm going to say manage NuGet packages. Let's see if there's some updates. Oh, look, here's an updated package. Let's update it. Yes. The scariest part of this demo, conference Wi-Fi. It looks like that package updated correctly, and we can now see the new number here. So we'll fire it up, and now we have a .NET 7 website. We upgraded our .NET Core 3.1 or 5 or 6 website just by flipping the number and updating NuGet packages. And now we can see that the website is going to work exactly as it did before. We've got an MVC page right here. We've got a Razor Pages page right here. We've got a WebAPI page right here together with the Swagger details. It all just works. Cool. Any questions so far about upgrading from .NET to .NET 7? Excellent. Now, if you're going to stop here, that's totally fine. But let's see if we can push it further. Now, one of the things that is really interesting here in, let's pull up home controller. We start out by indenting 4 spaces for our class. We indent another 4 spaces for our method. We indent 4 spaces. I'm at 12 spaces in, and I haven't even said anything yet. Okay, we could change it from spaces to tabs. We could change it to less spaces. We could definitely have that argument. But by default, I am 12 spaces in, and I haven't said anything yet. Let's see if we can optimize that a little bit. Now, one of the things that we notice is that typically we have a namespace up at the top, and then we never change it again. Well, if I have the entire file that sits in a single namespace, let's do the new syntax and make it apply to the entire file. Now I just pushed semicolon there, and VS Code, Visual Studio just automatically unindented it that far. Yes, I realize I'm about to change every line in every file, so git diff is now completely wrong. But we've now got a file scope namespace. Now, if I'm auto-generating code, or if I have a file that has multiple namespaces in it, I can still do it the old way. That's totally fine. But if I like this new style, I'm now indenting only 8 spaces to get into my code. That's kind of cool. So let's do that. Let's come around to all of our other namespaces, and we will indent them using file scope namespaces. There's one there. There's one here. There's one here. There's one here. I never understood why weather forecast wasn't in the models folder, but okay. And now let's go find all of the namespace lines. Make sure I got all of them. Yes, excellent. And if we build this, we can see that it builds successfully. Cool. Now, we could have definitely stopped with just changing the file number, the version number, but this is kind of cool. We've now taken some advantage of some interesting things. Next up, using statements. Have you ever fought over a pull request where the answer was you've got an extra using statement, you forgot a using statement, you didn't sort the using statements? I hate that. No, just accept my code. I know I didn't, Visual Studio just automatically generated it. I didn't even scroll up that high in the file anyway. Just make that go away. We spend a lot of time fighting over using statements. And in fact, Visual Studio is about to tell me that I can remove all of these. And okay, so maybe we can have a build task that removes them, but then does it commit? And yeah, that's a whole thing. So let's centralize all of our using statements. I'm going to add a new file. Let's call this one usings.js or usings.cs. And this won't be a class file. Instead, this will be a global usings file. Global using system. Excellent. Anywhere in any code in this project that needs to say using system no longer needs to do that because this applies to all of the files in my project. So here inside of weatherforecast.cs, where that's the only using, it's now completely obsolete. I can remove it. And if we build, we can see that it still builds successfully. Cool. I just moved all of those crazy using statements from all of the files into one spot. So now we can argue about just one thing. Let's remove and sort in there. So let's come through in all of the rest of the files and let's come grab all of our using statements and we'll put them here in using.cs. And so let's go grab those. Let's go grab these. And 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 I think there's one more right here. Oh, that one doesn't have one. Cool. So all of these using statements, I want to now turn into global using statements. So a little bit of regex. Let's find the beginning of the line and let's add global dot into it. Magic of regex, that is really cool. Let's now take out the double global. Build. Let's go find all of the using in my code. Make sure I got them all. I did. Excellent. Cool. Now I love here in Visual Studio, we get the green squiggle saying, I think you already did that one. So let's remove all of those. Here's some, and I could definitely use the shortcut there, but I'm going to skip that one for now. Let's delete these, and this one, and this one, and these, and this, and this. Cool. I have now 16 using statements for my entire project. Now, if we have a library that has a conflicting definition, maybe especially in testing, the thing that defines it, we may want to specifically put that using statement inside that file, and we definitely can. But we could also centralize all the other ones. Let's create all of the system.whatevers and all the Microsoft.whatevers and all the oursite.whatevers and put those here in this global using file that applies to all things in our project. Now, there's nothing magic about this file name. We could have put it inside of the top of program.cs. We could have put it in a file named global. We could put it wherever we wanted. It's just a file. Now, that's kind of interesting, but this is a website, and there's probably some namespaces that get pulled in automatically are some usings that most projects might need to include. Now, we can tell from this project that it is a website. So could we just, say, automatically import those things? come in here and let's say implicit usings enable. Now, if I created a new project in .NET 6 or .NET 7, this would be in here automatically. But we upgraded a .NET 5 project, so it wasn't in here yet. Now, this implicit usings, let's build this again, and then let's go looking inside of our project. I'm going to go into this ASP.NET 5 folder, because that's the one we updated, inside the obj folder. And let's go into .NET 7, and let's look for this file. site.globalusings.g.cs. Because we turned on implicit usings, this file gets generated for us automatically. Now, the cool part about this file is these are all of the usings that just auto-magically get pulled in. So I'm going to set this at the top of my code temporarily, and that will help me find all of the green squiggles of things that are already in there. Oh, cool. All of these ones, this one, and now I can go delete all of these, and that'll be great. Now, this is interesting. Global using global colon. This first one says that it's going to apply to everything in the project. This one says that the namespace is a global namespace. What if I created a file where I said namespace site.system? Okay, first off, shame on me for doing so. But second off, because I've created this, then system no longer means what we thought it did. And so as a tribute to making sure that this is actually really the top of the namespace tree, it says global : . So yeah, we could go run around in our usings and do that too, but I'll just make the assumption that we're not being dumb about namespaces and just leave it. Cool. All of the usings in all of the files in this entire project are now right there. All 6 of them. Can we stop fighting about this in PRs now? Please? Please? Yeah, now we fight about exactly one file. Should I delete this one line? Sure. Okay, fight's over. We're done. That's cool. All of the usings from our project now are centralized in one place, and we don't have to worry about it in our code, trimming them back out, adding them back in. If we want to grab a specific library that may only apply to one file, and we don't want this particular import in all of the rest of the files, we can definitely put it at the top of that file, and that totally makes sense. But in the majority of the case, we'll probably put them here inside this global usings file. And if we start up our website, we can see that it still works just fine. We've used file scope namespaces, we've used global usings, we've used implicit usings, and MVC, WebAPI, or Razor Pages, and WebAPI all still work great. Any questions so far? Yep.
Most IDEs usually auto-add usings to your file. Can you configure the IDEs to add them to your global?
Good question. So a lot of IDEs are going to automatically put our usings at the top of the file. Can we get it to put in our global file? I haven't found a way to do that. There is no convention on what that file name is. And so I totally get that, it could go look for the file, but there is no the file. It's whatever we chose to name it and wherever we chose to put it, and it might be in multiple files. So Visual Studio is kind of like, I don't know. So yeah, it is unfortunate, and we'll see that in a bit, where it puts it at the top, and that may not be exactly where we want it. I'm not worried. But yeah, we're going to fight about that in a PR instead. Great question, thanks. Any other questions right here? Yep. Can I use an alias with the usings? Yes, I can. The cool part is I can also use the other usings where I specifically grab the static name and make all of the functions available without a class name. That's available in global usings as well. That does sound terrifying. Where did this function come from? I don't know. Yeah, okay, so we've got file scoped usings. let's take advantage of the new builder. Now, right here in program.cs, we have kind of an interesting thing going on. Now, as developers, we always look for public static void main. That's kind of the initiation of all the things. And here in public static void main, we create this host builder. We .build.run. What's this host builder? I don't know. I think that's Latin for bootstrap this startup file. It feels like that entire file is useless. All it's saying is startup is over there. Here in startup, we have nice sections that we can understand better. We've got this configure services where it sets up the IOC container. We've got configure where it defines the pipeline. Here's where magic starts to happen. Let's take advantage of the new builder though and get rid of this whole create host builder thing. That thing is just mayhem. Bye-bye. Var builder equals web application.create builder. Now we can pass in our command line arguments. That'll be helpful for if we have any overrides on the command line. It's still going to pick up our app config, our app settings.config, and it'll still pick up environment variables. But picking up command line arguments is interesting too. Now we'll set up IOC container. And then let's say var app equals builder.build. And then we'll set up our request pipeline. And then let's say app.run. Cool. As a developer looking for static void main to try and find out how my app works, that's a lot more understandable to me. Now we still need to do these steps, so set up IOC container. Well, it's currently in startup.cs, so let's say var startup equals new startup, and it takes in a configuration, builder.configuration, excellent. Then let's set up the IOC container, startup.configure services. It takes in nothing. Nope, it takes in services, so let's send in builder.services. And we're set up request pipeline, startup.configure. It takes in an app and an environment. Cool. Now, if we like that separation between program and startup, we can definitely stop here because otherwise this class might get a little long. But that's kind of the basics of how we set up our web server. But I want to take it a little bit farther. I don't really like this separation between program and startup. So I'm going to go grab these configure services details, and I'm going to set it right here inside of program. Let's put it right there. Now, we don't have a services. We could say var services equals builder.services. That definitely works, but I'm going to go the other direction, and I'm just going to say builder.services all the things. And there's actually a simpler way to do Swagger Gen. I could just leave all of that off too if I wanted to get extra spiffy, but I'll leave that in. When I create a new ASP.NET 7 project, it will actually not have this piece, which is kind of cool. Okay, let's now go grab our request pipeline. So here's all of the pieces there. Let's remove that from there and set it in here, which, by the way, means that we can get rid of the endpoints too. Thank you, VS. Let's say app.mapController and app.mapRazorPages. And now we can just get rid of this startup thing altogether. Goodbye, startup. Delete. Now there is one more spot here in program.cs where it needs env. Okay, app.environment. Cool. And we can build our app, and we can see that everything starts up just fine. Cool. Now, that's fun. We've kind of extracted away all of the mayhem of what is public static void main doing. And we can even take this a step farther. And the cool part is that this works here for program.cs. The unfortunate part is it only works here for program.cs. It does not work for any other files in our solution. But we can say, let's just remove that whole class and method thing. And because it's program.cs, we can assume that it is the public static void main method, and then here's just the contents of that method. Where did args come from? Yeah, we can argue about whether this is better or worse, but it's definitely possible, and that's cool. And this will build just fine. We now have taken advantage of that new builder, and we can kind of get more pieces in here to kind of define all of the specifics. Now for both Razor Pages and WebAPI and MVC, we've been able to upgrade our project from .NET 5 to .NET 6 and take advantage of these new C# 10 and 11 features. Any questions so far? Yep.
An async context at this point, or
Can we use async here in the program CS? Yes, we can. None of these methods are async, but yes, top level async and await works just fine here. Great question. So this is a minimal APIs talk, and we haven't done minimal APIing yet. Let's do that. So here is MVC, here's Razor Pages. Let's do this, app.mapGet. Now we can't do the home page because that's actually going to our home controller. So let's say API/minimal. And I'm going to route it to this function here, new message equals hello. And let's say name, let's grab name, string name, and we will make it optional. Nullable reference types is awesome. We could specifically say this is from query string or from body, but it's implied, so we'll just leave it that way. Hello name, and we'll give it a default of world, and let's give it an ID of, I don't know, 3. And here is this minimal API. Cool. We mapped get to this function. Together with WebAPI, together with MVC, together with Razor Pages, it's just another mechanism that we can use. We now have a fourth paradigm for building web servers. Cool. So we did map get. Could we do some more stuff? Let's say app.mapPost. Now I want to play with attribute routing here. So I'm going to say this is 1, 2, and that will give me 2 parameters. And so I'll say string 1 and int 2, and let's do some interesting things with that. Return a new message that is 1 and an ID of 2. Comma, there you go. Cool. So we get attribute routing in the same way that we had attribute routing with controllers. It just works. It'll go pick out those parameters and set them into place in our method to be able to pull in those details. Now I could give it some more validation about, make sure that it actually is an int, make sure it's positive. I could do other things in there with attribute routing. Perhaps I make this one optional and this one optional. I could definitely do that too. Oh, and it's saying, hey, can you do that? Cool. So now I've got a post. Well, what about a put? App.mapPut. And here I'll just do API/minimal. But here I want to do a little bit more in my method. Let's say I'd like to take in an object. I'll actually even say this uses a route. And let's do some validation. Bool valid, in this case it is true. Let's take in another object. And now if it wasn't valid, then we want to say return this dot bad request. And then we'll save, and then we'll return this dot OK. Cool. That works out great. Almost. In a controller, we're really used to saying this dot, or maybe we're just pulling it out of the controller. And so this refers to the controller. Well, what does this refer to here? It refers to this method. Now, this Lambda doesn't have a bad request thing on it. It doesn't have an OK thing on it. So how do we do these? How do we return interesting status codes? Well, we can do response. Is it response? Results. Results dot whatever. And so here in results, we have this object, go to definition, that can give us lots of different things. So status 403 forbidden. Here's a forbid async. Here's a sign in async. Here's a content async. All of the ones that we had are here inside of results, and they return an iResult interface. So we could choose to implement this iResult interface and do our own things. So one of the things I like to do is to be able to send a status code and a JSON result. And so we have a status code result and we have a JSON body result, but we don't have one that is both. So I spin up a new thing, I'll descend from iResult, and now I've defined my task that does interesting things. So that's how we do kind of larger methods here. Well, let's clean this up a little bit. I want to create a new model. I'll call this a minimal model. And it will have public int ID, public string message, and public minimal model optional of data. Yeah, I could definitely do a record and that would be interesting. I'll make message required, so I need to define it to a value. And now we have our minimal model. So now that we've got our minimal model, let's come back here to our program.cs. And now we can do some interesting things. Because I'm returning a minimal model, I can now take in a minimal model. And now I need to play the caps game because I was just returning lowercase things. But now we've got kind of more established pieces. Cool. All the things that we can do inside of controllers, we can now do inside of WebAPI, inside of minimal APIs. Any questions right here?
In traditional web APIs, you can control whether someone has to be authorized with those square bracket things. Can you do the
Great question. So how do I prevent the baddies from getting in? Can I do authorization? Now, what I would love to be able to do is to say something like authorize here, because that would feel a lot like a controller. And that's not how it works. So do I put it here? No, that's not how it works either, because here it's the map put method, and that's not really. So the way we do it is we do it like this. Require authorization. Now it requires somebody to be logged in. I could, in the same way that I pass in other things into the authorize attribute, I can pass in details here about what role or claims you need, or I can be able to even invoke a method to be able to pull your user identity and do interesting things. So in short, yes, you can validate authorization in the same way you do with controllers. Great question. Any other questions right here? Yep. How do I do dependency injection? Good point. So I want to be able to take in my data context in here. Now up here somewhere, I'm going to say builder.services.add transient, and I'm going to give it some thing to thing, or perhaps I have my data context, and now I want to here take in an thing. And it'll just pull in just fine. I could attribute it very specifically in the same way that I could say here, this is from query. It's actually not, it's from the API. I can say from body, or I can say from IOC, from services. And so I'll put this one as from services to make sure that you don't accidentally inject some post-body content that happens to include something that kind of matches my interface, and I end up taking yours instead of the one that I configured previously. But that's how we do dependency injection, is we just specify it as a parameter inside of our method. That's cool. Okay, so we've got this minimal API, and how do we test it? I'm going to save this project. I'll pull out my thing so that I don't do bad things later. And let's open up the testing project. Now here inside of our solution, we've just been live coding all the stuff. We started out with the .NET 5 project. We upgraded it to .NET 7, file scope namespaces, global usings, implicit global usings, the new builder, minimal APIs. We added a little bit more structure. And now let's take a look at testing. Just to save us a little bit of time, I added a new project, my test project. In this case, I'm using XUnit, but we could definitely use NUnit or MS Test or anything else as well. Now, I want to write a unit test around this weather forecast controller. Now, this weather forecast controller returns some random data, and I could take a little bit more control over that by adding a layer of indirection. Maybe I need a random repository that will give me things, but let's just assume that I just want to check that I have 5 results. Okay, so here's my weather unit test. I'm going to do the arrange act assert pattern. And so I'm just going to call the method. I'm going to call the get method on my controller. I'm going to get an enumerable of weather forecast. I will validate that it should not be null and that it has 5 items. I could definitely check for more things, but that's enough. Now, one of the libraries that I really like is Fluent Assertions, and here's why. I had here int expected equals 5, and I said assert dot equal expected actual. Oh wait, no, actual comes first. Wait, no, expected comes first, and my code compiles either way. I spent the longest time debugging the test, and I'm like, it's supposed to be 7. I get 7. It passes. Wait, no, it says it should have been 5. And it was because I had expected and actual flipped. So one of the things that I really love about Fluent Assertions, expected dot should dot do the thing. And here's my, or actual dot should dot do the thing, and here's my expected. That's cool. So the majority of my assertions actually say actual dot should dot equal expected. And that's the majority of my things. So here I could say expected, and here I could rename this to actual. And now it's really clear what is happening. And now I can very specifically identify this. The other thing that I did, part of Fluent Assertions, is this assertion scope. Now the cool thing is with assertion scope, it's going to run all of my tests. And it will show me all of the failures. Have you ever done this where the build fails? And it fails on the first assertion in your thing, and so you go fix it, and you kick off the build, and then it fails on the next one. And then the next one. The cool part about assertion scope is it will run all of them, give me all of the errors, and now I can debug it in one go, make all of them pass, and then commit it. I avoid all of those repeats. Now there is one other interesting thing here in this. When I want a weather forecast controller, it takes in a logger. I don't care what that logger is. That's not part of my test. My test is validating that I have 5 results, not that I logged correctly. So I don't care. Just make it go away. Well, since it's unused, I could make it go away like this. And I'm going to choose not to do that. Instead, back here in our unit test, I'm going to create a new mock. This is from MOQ or MockU or mock. And I'm going to take a mock of that iLogger of thing, and it will give me this logger. I can then create that new weather forecast controller, passing in that implementation of it, and it's just going to return null or blank or the default for anything that I call, and just make sure that that object exists. And now I have my weather forecast controller, and I can call controller.get. Or I can take it a step farther, and I can use AutoMocker. Now the cool thing about AutoMocker is that it's going to go automatically do the thing. It's dependency injection for tests. So I go create a new AutoMocker. I create an instance of this thing, and it will go fill in all of the details of all of the dependencies that I didn't need to specify. Or I can very specifically create a mock and implement the things that I want. And so that is actually really beautiful. So in this case, I create an AutoMocker, and I say, hey, mocker, go create me that weather forecast controller. And for all those things that I don't care about, I don't care. Just go figure it out. If ever you add a dependency to a controller and you have to run around to all your tests creating a new mock, AutoMocker will do that for me. I no longer need to change my tests. That's just amazingly cool. So we've got this controller. Now we'll go call that method, and then away it goes. Now that's great for unit testing. We've done this forever. How would we do integration testing? Well, here in integration testing, we need to, well, start up the web server. Oh wait, we need to go find an available port. So let's go find an available port. That one's not in use. Okay, so let's go find a random port. Let's start up our web server. Now we need to get that port number into our client. Now we need to create a request. There's all of this mayhem kind of going on to be able to do an integration test. This is cool. I can create an integration test where I create this new fixture that just does interesting things. Now this won't actually go out to do network requests, but it will instantiate my server and do the full request pipeline. It's all in memory, it's not over the network, but it will do all of the things that my server needs to do. Now this is cool. I have this web application factory of the program class, my program.cs that we built here. I can choose to override things. So I need to start by taking my thing out of the IOC container, and then I can put in a fake one, say my in-memory database. Or let me swap the connection string off to a connection string that is a test file database that I just implement for this thing. So I'll remove all the services I don't need. I'll add the fake services in that I do need. And now here in my test, I have an instance of my application that is effectively running. I now create an HTTP client from that. And now I have a client that works the way I'd use HTTP client anywhere else. So let's do a network request to API/weather forecast. We'll read the string as async. Yeah, I could definitely do read JSON async, but in this case, I kind of wanted to do it the manual way. Let's deserialize that into a list of weather forecasts. It's optional because I might not have that body here. And then I'll do the assertion scope, and I should have 5 weather forecasts there. Cool. Now there is one more piece. It's going to be a little bit mad at me. It's going to say, argument null exception dot throw if null weather forecasts name of weather forecasts. And the reason that it does that is that C# going to check the nullable reference types doesn't know that this should not be null is doing that too. So yeah, I have to go add one more check. This line will never get cut, never get executed. It will never throw here, it can't. but now the C# compiler that looks for nullable reference types will be happy too. Okay, so in the same way that we did this integration test, we can do an integration test of our minimal API. So we'll pass in name of test, and then we expect that body to be hello test. That's how it forms it. Now, why is the ID 3? Because I hard-coded it that way. Ideally, we would pass in something else, but yep, that's how we can test our minimal API. We'll just fire a request at it, we'll get the response, we'll deserialize it, and we'll do the things. Similar, let's go test our post. We'll go fire up a post body, we'll send that off to our minimal API, and we'll grab the response there. So let's build it. And of course, our build is going to fail. Why did the build fail? The build failed because program is inaccessible. Yes, here in our program.cs, we have it auto-generate all the things, and that's great, but by default, it makes a private class. Now, we could definitely do internals visible too. We could, try and create a friend assembly, and that gets really weird. Or it actually creates a partial private class. So let's define the other half of the partial class. Ta-da! And now it builds. That is such a hack. I hate this. This is awful. This hack is just nasty. So of course I'm going to comment it. Public for testing. And now it's a little bit less painful. Yes, it's a hack. I wish it created it public by default, but it doesn't. I understand why it doesn't. But yeah, if I want to test it, I need to make it public. Cool. So now let's start to fire up all our tests. I'll come here to the Test Explorer. I happen to have it right here, and it is tiny. So let's take a look at our tests, and let's run all of our tests. One of the things that I like while we're here in the Test Explorer is that I can come in here and I can say, run tests after every build. Now, if my tests are pretty fast, then that's great. I can just, anytime I build, it'll fire up my tests. I can see if I'm succeeding or failing. Live unit testing is a thing, and this isn't it. But this is really nice. If my tests are fast, that's cool. Now, in this case, my tests aren't, but all 4 of our tests are passing. I didn't need to figure out ports. I didn't need to start up a server. I didn't need to kill it at the end. I just said, hey, go fire up the thing, HTTP client that I'm already familiar with. My tests work great. Any questions so far on testing? Yep.
Not specifically testing, but for the throw if null line you added in, is there a particular benefit to using that over the exclamation mark operator?
Good question. So here I said, I would like to throw if null. Could I have instead used the null coalescing operator and just said, no, really, it isn't? Is there a benefit or drawback from that? I like to use the null coalescing operator as the last resort. It's like, this feels like I'm telling the compiler that it was wrong. In the most cases, I'm actually wrong, and so I try to use that as sparingly as possible. Is that more or less legible? I tend to miss that. I read the first couple of characters in the variable name, and I think, and so I won't see this, but I will see this. And so I would argue that this is more, well, self-documenting. I tend to code for legibility, and so I prefer that. Is it better or worse? It's a preference thing. And if your preference is the other way, then that's great.
I'm just curious whether there was any noticeable difference beyond what you could read.
Is there a notable difference? Not that I know of.
Cool.
Yeah, great question. Any other questions right here? Yep.
If you're authenticating, can the HTTP client you were just showing, can that be modified to skip or get around the authentication to so you can test your methods?
Good question. So if I have to do authentication stuff, can I skip the authentication for my tests? Now, there's kind of two sides to this. The one side is, yeah, if I skip authentication for my tests, am I really validating that the entire site works? And so maybe I need to first hit the login page or the login API and get my JSON web token, my JOT, and then pass that into the other tests. That could be one way to go. Or here we're saying, what is the environment? And right now the environment is development. So I could say in my authentication mechanism, but in development, don't authenticate. Now at that point we lose all of the user context. So maybe we're saying if the environment is test run, and now in test run my authentication is disabled, and I could definitely do that instead. Yeah, that was awesome. Any other questions right here? Okay, so we've got our tests, and this is working out well. I'm going to go back to our other app that doesn't have tests and continue on there. Why, yes, let's save all of that. Now, we might have, I don't know, half a dozen models in our thing. We probably have 4 methods per model. And of course, I'm going to put all of my stuff at the bottom, and you're going to put all of your stuff at the bottom. And so we're going to end up with these merge conflicts where the merge starts to zipper our methods together. And of course, I don't want to deal with that any more than you do, so I'm going to take mine, and you're going to take yours, and our code is gone. Can we make this a little better? I'm going to take all of this out here, and let's just make up a convention. I will create a new folder called APIs. I'll create a new class. I'll call this minimal.cs. File scope namespaces are awesome. And let's say, let's make a get method, public minimal model, get that. Let's make a post method. So let's go grab this, and we'll say public minimal model post. There is that. We'll grab this and we'll make a put method, public response, put, and we'll do that. We no longer need this. Oh, it's not iResponse, it's iResults. Oh, hey, we need a using. Oh, no, it's just mad. iResult. It is singular. Cool. And then, I don't know, let's invent this method, public void init. Let's take in an application or a web application. We'll call this app. And then let's map get to the get method. And let's map post to the post method. And let's map put to the put method. And now let's come back over here into program.cs. And I will say var minimal equals new minimal. And minimal.init and pass in app. Or, oh, I need a using statement. Thank you, but I would like this in my global usings, please. I wish it did that automatically. But back here, now this, I don't really want to new this, so I'm going to say app.services.getRequiredService of type minimal, and I'll just yank it from my IOC container.init app. And I could make that an extension method, and now it's one line. So, okay, now we were fighting over the merge conflict. Now, my merge and your merge, they're one line, and it'll probably make them separate, and I think that's okay. What does this look like? It looks like a controller. Why don't I just, well, I don't know, use a controller? We've gotten to the illogical conclusion of minimal APIs. Let's presume that we have half a dozen models. We have 4 methods each. We're going to do all of this mayhem. We may as well just use WebAPI. This is not the right tool for the job. We have gone too far. Minimal APIs is great for small problems. If we have enterprise applications with lots of models and lots of methods, WebAPI is right there. It's not deprecated. Let's use that instead. Instead, let's take a look at what the right use case for minimal APIs would be. So I'm going to close this solution, and let's open up this project right here, the right size. Now here in the right size project, I have this interesting JSON file, and my task is to put this online. That's it. Or accept a form post and send an email, or accept a webhook and alter the data in some way. I just need to do this one little thing. I just need this online. This is the right size for a minimal API. Now, the cool thing here is that in this project, I have exactly one C# file. It's this program.cs, and that's all. I happen to have a few JSON files kicking around. They aren't necessary. I could definitely delete them, but that's fine. Let's pop open program.cs. Now, here in program.cs, I create a builder. I add some stuff to my IOC container. I'm going to go read that interesting config file, and I'm going to then deserialize it into the strongly typed object. I defined a record down here, record class, the interesting config. And so now it's a strongly typed deserialization. I'll throw if it's null, and then I'll add it to my IOC container. Now, I chose to put it in curly braces right here just so that I can't cheat and just grab the thing straight out of the other file. I want to definitely leverage my IOC container. app.build. And now, if you call this endpoint, I'm going to go grab that interesting config and I'm going to return it. So let's fire up this website. Now here's this website. We've got Swagger on it. That's awesome. Let's try it out. And we get our interesting config. Cool. Now, as any good endpoint, we also probably want to handle not found pages, so not a valid page here, and here's our 404 page. We probably also want to do error handling, so let's go to error, and we get a 500 error. We also probably want to do some health checks, so let's go to the health checks. All best practices with a service. How did we do that? Well, we wanted to rig our 404 page, so we're going to go grab star, meaning anything else. So go grab the rest of the URL, and let's map it to this not found page. Now, originally, I just had this as blank, and so I got Chrome's default page of saying, hey, there's nothing here. And I wanted to say, let me show some content. I thought it was my network connection, so I returned not found. I want to map the error page to results.problem. Now, I chose to map the errors to the error page, so any error that happens in my application will naturally land on this page. How did we do health checks? Well, I say .add health checks, and I map health checks to the health URL. So now, if Kubernetes notices that my container isn't returning this 200 on my health page, it knows that my container is probably unhealthy, and it can automatically restart it. That's perfect. All of this in 46 lines of code, including that hack to make this app testable. This is the right size for minimal APIs. If we need to upgrade to have dozens of models, then WebAPI is right there, and we don't want to deprecate it. It's still right there. It's a great solution. If If we want to upgrade to having even less details about it, Azure Functions or Knative Functions are right there, and we can leverage that. For those small problems where we want to take control over the HTTP request and we want to just do something real fast, we can upgrade to minimal APIs. WebAPI, MVC, Razor Pages, and now minimal APIs. We now have 4 paradigms for building websites inside of ASP.NET, and as we can see in this app, they will all play nicely together. Use the correct one for the job, and you can accomplish great things. Minimal APIs is right here, and the code for all of this, including that correct solution, is up here on GitHub right now. Thanks for coming.